To introduce Professor Linda Basson with something, the following, some information she sent us. I studied at the University of Johannesburg, then, of course, still known as RAU, Rand University, Afrikaans University, where I obtained all my degrees, BSc Geology and Entomology, BSc Honours in Zoology, MSc in Geology, and PhD in Zoology. Accepted an academic position in 1988 at the University of the Free State and the Department of Zoology and Entomology. Was lecturer from 1988 to 1991, senior lecturer 92 to 97, associate professor 98 to 2005, and full professor since 2005. The research field is on aquatic parasitology, visited several countries for search, including Mauritius, Israel, Taiwan, Australia, Botswana, Namibia, Senegal, Egypt, Marian Island, and of course, Antarctica. A total of 17 MSc and 7 PhD students have obtained their degree under my supervision, where the majority of my students have worked on ciliate parasites from the marine and freshwater environment from various hosts such as fish, molluscs, marine, freshwater, and terrestrials, frogs, planktonic custodians, sea cucumbers, etc. Published more than 55 scientific papers in peer-reviewed journals. Delivered presentations at many national and international conferences. Linda, I don't know how you managed to do all this in this little short time, what it looks to me, but anyway, thank you very much. I'm sure this is, you will be well equipped to really tell us about this fascinating world where you live in. Thank you. And
thank you. Well, a lifelong dream of mine was recently realized. Two places, the Amazon and the Antarctica, has always been at the top of my bucket list of places to go and visit, not for a holiday, but for research. And now I can declare that one of my dream places may officially be ticked, but let's note, only ticked. I'm going back there. I have traveled to the bottom of our planet, to the driest, coldest, and the windiest place on Earth, and I am going again. One trip was a mere teaser for me. So two Kopsies set up on this epic voyage. We were both a little scared. Gerard de Jaar, and a PhD student of mine, and myself, of course, were both invited by Professor Isabel Ansorge. She's head of oceanography at UCT. We were part of the Sanai 59 takeover voyage that took the new takeover team to our base in Antarctica called Sanai 4. And we were also there to retrieve the team that has been there for a year. While this was a logistics trip, there were also a variety of scientific activities with scientists from various institutions and also from various countries. This was a unique opportunity for all of us, not just to do our type of research, but also to work closely with several excellent and very dedicated scientists. We left Cape Town Harbour on the 10th of December 2019 and arrived at the ice shelf a mere 7 days later. The journey from Cape Town to Penguin Bukta, where the ship offloads cargo and people for the trip inland to our base, normally takes 14 days, and we completed this distance of 4,800 kilometers from Cape Town to our the ice shelf in 7 days, half the time. So this was record time, because we journeyed through very strangely storm-free waters. Normally, when one travels through the roaring 40s and the furious 50s, there are endless delights in the forms of raging storms and violent squalls. I was immensely disappointed by the becalmed seas, but my fellow travelers did not share my disappointment, of course. The roaring 40s are regarded as the roughest seas on our planet, and the impressive storms there are legendary. So the furious 50s winds are mythical, and none of these temper tantrums of nature realized. I found that an immense letdown. The SA Agulhas II is South Africa's renowned premier vessel for research in the Southern Ocean. The ship is utilized by a spectrum of multi-platform instruments used on a routine basis for monitoring oceanographic and biological parameters. She not only visits Antarctica on a regular basis, but also Marion Island and islands such as Gough and St. Helena. Our entire voyage of 3 months was divided up into 2 legs. First, the 10th of December to the 16th of January, and the second leg from the 23rd of January to 28th February. Our voyage took place in full summer, the only time of the year when we can actually do a logistics trip to this part of the world due to the weather and the ice and the furious storms during the winter. During summer in Antarctica, of course, the sun never sets. 24 hours of daylight. At least we experienced that full on during the first leg. This was both marvelous, but also inconvenient for some people. One had to close one's blinds at night in the cabins to sleep undisturbed. During the second leg, we had very short nights, basically only a brief dusk and a dawn. A total of 37 scientists took part in the research during the takeover voyage. Some, like the 2 of us from COFSIS, did both the legs. These scientists represented 9 tertiary institutions. A wide spectrum of data was collected that varied from long-established projects that's been going on for many years between several countries to brand spanking new endeavors such as our own. Projects there are very topical, concentrating on various structures and areas on both, but all of them focusing on the Southern Ocean in peril. A few of these activities that I will just mention here are the radar sensing remote data of 2 German satellites were used. This is a collaboration between South Africa and the German Aerospace Center. This specific data enabled the SA Gullis 2 to plan optimal routes through the sea ice to save time. This was not to save our noble vessel. This ship is more than capable of crashing through very thick ice. Another collaborative project is between South Africa and Italy, where the Italian Murcia project provides a framework for the worldwide drifter programs and the Argo datasets. These are sensitive instruments that we launch in the ocean. I'll tell you a bit later about this. So this project collects and analyzes seasonal and inter-yearly variation of the surface currents and the thermohaline characteristics of the ocean. Then there were several other scientists and groups carrying on with the existing research, mostly South Africans and all eminent scientists regarded very highly worldwide due to the excellent work that they do. I think we as South Africans can be very proud of their high international standing. The UCT team, which is always a very strong team on board the ship during the Antarctic research, they launched XBTs, as you can see here, every day on both the legs. And they did this from the aft deck, the poop deck, where they launched these things over a 24-hour period, so day and night, sometimes under harrowing climatic conditions. These expendable XBTs instruments determine depth and temperature up to 2,000 meters in the ocean. And then the people of the South African Weather Bureau, they're a fixture on board. They deployed weather balloons daily, sending this data directly and immediately to the office of the Pretoria Weather Bureau. The Bird and Mammal Research Group manned the deck above the bridge every day from 6 to 6, only when the boat was in full cruise. The same team also monitored pollution, specifically plastic observations. During the complete voyage of 3 months, they observed 4 species of seals, 52 different marine bird species, and 16 different species of cetaceans, which included both whales and dolphins. A total of 616 whales were observed, of which the majority were humpbacks, and that was 445 humpbacks. And then very excitingly and remarkable, also 2 blue whales were recorded during the whole voyage of the 3 months. Actually, I should say only 2 blue whales were recorded. I find that very, very sad. So during this 3-month trip, several sensor instruments that I mentioned earlier with the Italian Murcia project, for instance, were also recovered during the voyage. Numerous ones were also launched. These extremely sensitive instruments are capable of bobbing around for a whole year in rough seas, while they continuously collect various kinds of data. But unfortunately, this data can only be recovered when the instruments are recaptured. And this is a very intense and stressful operation in the rough Southern Ocean. Here you can see students of the Cape Town Technikon busy setting up one of these very delicate instruments for us to launch. These photographs that I took shows when we actually succeeded in successfully recovering one of the older instruments that was launched the year before. We also had 2 failed attempts where both the instruments were irrevocably lost. This is both a heavy cost in the data that was lost, but also that we lost 2 very expensive instruments, because once you lose them, they can never be recovered again. I will give you a brief presentation on what our research consisted of a little bit later, but first I would give you some information on this part of our planet. The old tales of discovery to the poles always fascinated me as a child, and several hero figures were very high on my list. I can, due to the time constraints, only mention 2 of these heroes of mine. The first is Roald Amundsen. He was a biologist and an oceanographer, and surprisingly also a politician. He was Prime Minister of Norway, the first Norwegian ambassador for the League of Nations, which was a precursor to the United Nations as we know it today. And the well-known Nansen passport is a passport provided today, even today, to stateless refugees, actually refers to this exceptional man. He also received the Nobel Peace Prize in 1922. The Fram expedition refers to his famous journey with his ship, the Fram, to reach the North Pole. His techniques in polar travel and his innovations in both the equipment and the clothing have assisted subsequent people going on excursions since then. So many explorers was actually assisted by his innovations. But the person for which I have the highest regard is the Brit Ernest Shackleton. He led various expeditions, the 1907 to 1909 Antarctic expedition in the Nimrod, and then the transatlantic expedition in his famous vessel, the Endurance, to the Weddell Sea that lasted from 1914 to 1917, and I'd like to tell you a little bit about this. Shackleton and his team sailed from England in August 1914 to the Southern Ocean. They stopped off at South Georgia for a while and left South Georgia on the 5th of December. On the 19th of January 1915, which is full summer, the Endurance was trapped in sea ice in the Weddell Sea. On the 24th of February, the crew realized that the ship was lost, and they established a base on the ice next to their stricken ship, where they tried several times to free their vessel from the deadly ice trap. By the 24th of October, now you realize that several months later, the ship started to leak, and on the 21st of November, the stately and glorious vessel slipped beneath the ice forever, stranding her whole crew on the ice. For a further 2 months, the men camped on a large floating ice sheet, but the drifting ice didn't take them closer to Bullet Island as they had hoped. On the 9th of April, the ice sheet started to break up, and Shackleton ordered everybody into the 2 lifeboats that they had. For 5 days, they endured harrowing conditions before reaching Elephant Island. This was solid land for the first time for his men in 497 days and 557 kilometers from where the Endurance actually sank. But this was not a rescue. Elephant Island was uninhabited and inhospitable. And Shackleton took 4 men with him and one of the lifeboats and set out again into the rough southern seas, this time for South Georgia. They were exposed to the deadly ocean, and 15 days later, they reached a remote part of South Georgia. 3 of them, including Shackleton, started a dreadful journey over snow-covered mountains to the base in South Georgia, a mere 32 kilometers that took them 36 hours. And then they reached the whale station at Stromness on 20 May. He immediately organized help to get the 2 other men stranded on South Georgia. But his men on Elephant Island still had to wait much longer. He succeeded, after some struggle, to convince a vessel to travel to Elephant Island during the stormy season, and he reached his men on the 30th of August, 4.5 months after he left them and one of their boats on Elephant Island, and 2 years after they left England. He did not lose a single man, despite the grueling conditions of 2 years in surely the most inhospitable place on our planet. War had broken out in the meantime, and a number of his men were called up for service. Several of them died in the First World War, some with him within the first few weeks. I find that personally cruelly ironic. Not less than 17 large Antarctic expeditions have been carried out from 10 countries, all before any big development in transport and communication technology. These were truly tough, brave men. By marking this era as heroic was only later given to these times and events, and then this was done to give recognition to these pioneers that often did not survive the grueling expeditions. A total of 19 members of expeditions died during this period. So both the geographic and magnetic South Poles were reached for the first time during this heroic period. The major aim of most of these journeys was to reach the geographic South Pole for the first time. And this honor belongs to the Norwegian Roald Amundsen, who reached it in 1911. Geographically, Antarctica is defined as the Antarctic continent and the islands on the continental plate of Antarctica, but also including islands not lying on the continental plate, but that are considered to be part of Antarctica. These islands include the South Orkney Islands, the Southern Shetland Islands, South Georgia, the South Sandwich Islands, Bouvet Island, and Heard and McDonald Islands as well. Antarctica is the coldest place on Earth. The lowest temperature measured was minus 94.7 degrees centigrade, and this was at the South Pole. Temperatures reach a minimum of between minus 85 to minus 90 degrees in the winter, and this is Celsius, and a balmy 30 degrees higher during the summer. For humans, ironically, sunburn is the biggest problem in Antarctica, as snow reflects more than 90% of the sunlight. Weather fronts seldom penetrate deep into the continent, leaving the center very dry and very cold. Gale-force katabatic winds regularly blow on the edge of the continent, originating from the polar plateau. Inland, one normally finds far more moderate weather and wind speeds. There is very little precipitation or rain, the South Pole with barely any. This is the continent with the lowest air humidity as well, thus the biggest desert on our planet. It is also the most windy and the highest average continent. The highest peak in Antarctica is Vinson Massif, 4,892 meters high, and situated in the Ellsworth Mountains. Antarctica also has many volcanoes, but only Deception Island and Mount Erebus are still active. Mount Erebus is situated on Ross Island, and small eruptions occur there regularly, and lava flow has been observed in the last few years. A submerged volcano was discovered recently in 2004 in the waters of the Antarctic Peninsula, and this volcano appears to be very active. The continent is almost completely covered in ice. 90% of the ice of the world is found on the Antarctic mainland. The average thickness of ice varies from 2.2 kilometers and 4,776 meters at its thickest point. Most of the ice is millions of years old, but not the whole of Antarctica is covered in ice the whole time. A British-Swedish expedition discovered in 1949 that large parts of Antarctica, such as Queen Maud Land, where our station is based, was ice-free until about 10,000 years BC. Roughly 98% of Antarctica is covered by the Antarctic ice plate. This has an average thickness of 2.5 kilometers. This continent contains 90% of the world's fresh water, all trapped in ice. Antarctica also has 70 lakes, thousands of meters beneath the surface of the continental plate, with one directly beneath the South Pole as well. Western Antarctica is covered by the Western Antarctic ice plate, which has been the source of serious concern lately to its possible collapse. If this plate does indeed collapse, sea levels worldwide will rise a few meters in a relatively short period of time. But the largest ice cover in Antarctica is also of grave concern. These images show the shrinking of the ice plate just over a period of 6 years. And these photographs, remember, were taken in September, which is basically the end of winter. Antarctica has a surface of 40 million square kilometers, which makes it the 5th largest continent. It is surrounded by the Southern Ocean, confirmed recently that it is actually the largest of our oceans on Earth. The coastline is about 18,000 kilometers long, and the continent is divided up into two parts by the transatlantic mountains close to the neck between the Ross and the Weddell Seas. The western part of the part west of the Weddell Sea and east of the Ross Sea is called Western Antarctica, and the biggest part of the rest is then Eastern Antarctica. As far as resources go, Antarctica has very good coal resources, with the Prince Charles Mountains containing significant iron ore deposits. However, the most valuable resources lie along the coast. These are oil and natural gas fields discovered in 1973 in the Ross Sea. Luckily, all mining activities are prohibited until 2048, and this is by the Protocol for Environmental Conservation of the Antarctic Treaty. Antarctica is not under the political sovereignty of any nation, but Argentina, Australia, Chile, France, Norway, New Zealand, and the United Kingdom maintain area claims, but most other countries do not acknowledge these claims. The claims of Argentina, Chile, and the United Kingdom also overlap one another quite a lot. Human activities on Antarctica are subject to the Antarctic Treaty that was signed in 1959 by 12 countries, of which South Africa was one of the original signatories, and our own claim has been implemented since 1963. The treaty prohibits any military activities, supports scientific research, and protects the continent as an eco-area. There are no permanent human inhabitants in Antarctica. As for vegetation, there isn't really any vegetation to speak of due to the climate. Icy temperatures, poor soil quality, the absence of moisture throughout the year, as well as limited sunlight, which is only present during the summer months, restricts the possibility of any plants to exist there. Flora on the island and in the ocean mainly consists of lichens, bryophytes, fungi, and algae. These basically only show growth during the summer months and then only for a few weeks. Multicolored algae and diatoms are plentiful in the coastal regions during the summer, and here you can see some of the photographs we took under the microscope of the plankton that contains phytoplankton and algae that we collected around the coast. Permanent land animals are not vertebrates as most people think, but invertebrates. These include microscopical mites, lice, and springtails, also called colembula, which is a group of primitive arthropods relatively closely related to insects. The largest land animal in Antarctica is a gnat, which is 12 millimeters in length. The snow petrel is one of only 3 birds that breed exclusively in Antarctica, and snow petrels have been seen inland as far as the South Pole, which is the only bird that travels that far. A variety of marine animals are directly or indirectly dependent on phytoplankton in the ocean. This rich sea life includes penguins, whales, and fur seals, many other seals as well. The emperor penguin is the only penguin that breeds in Antarctica during the winter, while the much smaller Adelie breeds further south than any other penguin, but it breeds during the summer. Other penguins that occur in the Antarctic region includes macaronis, gentoos, the king penguin that here visited our ship during our brief visit to Marion Island, and chin-strap penguins that we captured here close to Thule Island, and I will come back to Thule Island a little bit later. Antarctic krill occurs in enormous numbers and schools in the Southern Ocean, and they are without doubt the keystone species here. They are crucial for the survival of many species. Krill forms a vital source of food directly or indirectly for whales, seals, fur seals, squid, icefish, penguins, albatross, and many other birds. Unfortunately, humans also utilize and therefore compete with all these animals, and we use krill as an ingredient for pet food, also fish food and fish bait. And unfortunately, we have found out recently that this source is not inexhaustible. Research stations in Antarctica are either permanent or seasonal. 14 countries maintain several permanent stations, and population numbers on the continent can therefore vary. During the summer months, when most stations are manned, there can be 4,000 people on Antarctica, which dwindle to about 1,000 during the winter. Researchers include biologists, oceanographers, geologists, physicists, astronomers, glacier experts, and of course meteorologists. Since the 1970s, the studies also focused on the ozone layer. The largest hole on record was in 1998 over Antarctica with a massive 27 million square kilometers big, which is much larger than the whole of Antarctica. South Africa has two stations, a seasonal summer station at the top picture there, and a permanent base. Our permanent base is Sunhigh 4, built and completed in 1997 and situated in Queen Maud Land. This base is part of the South African National Antarctic Program, also known as SANParks. Teams stay for a year and are swapped every year during the summer. The new team is taken to the base in December and is then trained by the previous team. At the end of this training period, roughly 3 months later, the old team is taken to the SA Agulhas, who takes them back to Cape Town. The SA Agulhas normally anchors at Penguin Bukta, where the crew starts to offload supplies, fuel, and apparatus onto the ice shelf, which is 30 meters high, and you can see it towering above the ship here. The technicians are also swung over, and these technicians then take the supplies to the base on skidoos and a lot of other different snow vehicles, all laden with fuel canisters and items that are too large to take to the base by the 2 helicopters that are also found on board. The helicopters can actually fly several times a day, but this is weather depending, of course. Where the skidoos can drive through storms and strong winds, the helicopters can't. Before I get to my research, I'd like to just tell you about some amazing experiences I had in Antarctica. We had a very brief visit to South Thule Island. None of us could get off, only the 2 people from the Weather Bureau. This is a small island that's part of the South Sandwich Islands. It's very inhospitable and windblown, and it also belongs to the United Kingdom. The island forms part of an old sunken volcano and is covered with ash and penguin guano that reeks to high heaven. Here you can see us when we were just stationed while the team went on land. The sea surrounding the island teems with marine life such as the chin-strapped penguins that I showed you previously. As I mentioned, it's administered by the United Kingdom since 1908, but in 1975, a team of, a group of the Argentinian Air Force landed on the island, and they started building a small military base, barracks, and a cement helicopter landing area. They also erected a weather and a radio station, and the flagpole, of course, streaming the Argentinian flag. The Brits realized this in 1976, and they sent a very large commando in 1977, consisting of a nuclear-powered submarine, 2 frigates, and 2 support vessels. But despite showing this strong arm show, they did not dare go on land, and they didn't do anything, so they didn't use any force. On the 20th of June 1982, the Royal Marines landed and the Argentinian garrison surrendered. 6 months later, however, a passing British warship saw that the British flag was removed and replaced with the Argentinian flag. The Brits came back and this time destroyed all the buildings and the structures on the island. These wreckage heaps are all that is left, cheerfully eroding away in the very fierce climate, the only reminder of the absurdity sometimes of countries and humans. Today, South Thule Island is used by countries such as South Africa, where we maintain a small weather station, where we download and use the data, of course, with the necessary permission in triplicate from the British government. We also had the most amazing opportunity to get off on South Georgia for 1 whole day. After going through rigorous cleaning measures to prevent us from inadvertently transporting any foreign material to the island, we were taken in small groups in motorboats. South Georgia is another British territory. These islands are remote and also very inhospitable. There is no permanent human population, but there is a small non-permanent group that lives there. The island used to be the base of whale hunters in the 20th century, but whaling was stopped in the 1960s, and Great Viken still shows the ruins of this bygone era with very large metal drums rusting away into oblivion, in which the whale fat was fried out and then stored, as well as bleached whale bones lying everywhere, as a silent reminder of the atrocities of those days of yore. This island group is a breeding paradise for many animals, different albatross species, large king penguins, and numerous other bird species, and of course, a very, very large population of fur seals. The ocean surrounding the islands harbors astoundingly high levels of biodiversity, and it was discovered recently that South Georgia actually has one of the highest biodiversity levels of all ecosystems on our planet. Ernest Shackleton, that I told you about earlier, died on board his vessel in 1922, and he was laid to rest in the graveyard of Great Vicken, a resting place with an unforgettable view of King Edward Cove, where you can also see the Agulhas when it offloaded us. Then we had a Christmas to remember. After we'd been on board the SA Agulhas since 10 December with no chance of getting off on land, the captain decided to treat us on Christmas Day. The ship cruised around the previous day without us realizing that the captain was searching for a very special spot, a safe, solid ice plate. On Christmas Day, he allowed us to disembark onto this ice plate, of course, and he reminded us of the strict rules of the Antarctic Treaty. We were not allowed to approach any animal. We were not allowed to discard or dump anything whatsoever on the ice, and we were not allowed to wander off into any direction or far from the ship or any one of the people on the ice sheet. Pumped full of the rules, we were set free, although the wandering around and wandering off was the captain's rule. Immediately when we got on the ice, Adelis approached us. No one obviously informed the Adelis about the treaty rules. Here they were waddling off, appeared at the ship for a very long time. Adelis are endearing creatures, full of verve and chutzpah, and they captured our hearts. Here you can see us on the ice with the Adelis wandering between us, peering at us. There was also one single penguin, an emperor penguin. It was a youngster, but he stoically ignored us, even this early in its life, showing the characteristic life-weary and slightly haughty attitude of the species. Without doubt, this was the best Christmas present I have ever received. And then the day of the whales. We were up very early one morning because we had to recover a slocum, a type of sensor instrument, and we suddenly noticed 2 humpback whales spy hopping. More of these whales approached our vessel, coming very close, and all activity ceased. According to the treaty rules, the ship stopped to prevent any whales from being injured, and for several hours we couldn't carry on looking for the slocum, but we were enthralled by the whales coming to watch us, so we weren't sure who was studying whom during this time period. And this brings me to my research. My field of expertise is parasitology, and I'm an aquatic parasitologist to be exact. My research group is parasites mostly of fish, but increasingly also other hosts, including several invertebrate hosts as well. My personal field of interest is a group of parasites that belong to a single cell group where they have a very hard skeleton called denticles. These ciliates are associated with a very wide number of invertebrates. You can see here, these are all hosts that we have found them on, and then several vertebrate groups as well. Our team, which includes a colleague of mine and our postgraduate students, have 2 very large projects at present. One of these projects concerns the parasites of a large variety of vertebrates and invertebrates in the intertidal zone specifically, so in the marine habitat. Our second other very large project that has been going on for 24 years, we look at fish parasites in the Okavango Delta and in the river. So we have been going to the Okavango River for many years, and we always camped somewhere in the Okavango. But in 2007, we built a permanent research camp in the north of Botswana with a laboratory and all the amenities that we need to do our research. Up to now, our research group have produced the collection and the description of 200 species of parasites, of which more than 50 turned out to be new species. This is one of the new species that we actually found, one of the fish lice in the Okavango, in one of the fish that only occurs in the Okavango River. So on the back of tiny parasites, I have had the privilege of traveling to many places in the world. And one such a destination, one of our last trips was Antarctica. It was in this storm-ravaged part of the ocean that I realized that I loved the wild, untamed storms of the southern seas, the strong winds in the wild seas with monstrous waves breaking over the bow of our magnificent ship. It literally made my blood fizz. And to look for my nunus, where very few people get to go and where very few people actually choose to work on, this was absolutely a dream come true. Oceanographic research has been done for many years in Antarctica during the summer takeover periods. However, no one has ever looked at the parasites, and no one has looked at parasites on board the SA Gullah. So this was new. And in my search, I found one single scientific report where they reported on parasites, but no species of parasites were identified. So for our kind of research, the hosts must be collected alive, and we have to work through them immediately. We cannot examine frozen fish or dead specimens. In other words, we parasitologists must be there in person, and we have to do our own dirty work. Yay! So the two of us, Gerard, Diar, and myself, we were shipbound, which meant that we did all our research from the ship. Gerard was also appointed as the chief scientist by Isabel, and this meant that he oversaw all scientific activities as well as the organizing and the execution of all scientific endeavors, which meant that I sometimes didn't see him for days in the lab. Our research was explorative in nature to determine whether we could do our kind of research from the ship, what kind of apparatus we would need to develop in future to be successful. And due to the complete absence of robust parasite research, Antarctica as a destination wasn't just a dream come true, but a true paradise for a parasitologist. Collection for us could only take place when the ship was stationary, something that didn't happen very often, and of course, when weather conditions allowed. During offloading of people and supplies at Penguin Bukta, and again at Akta Bukta, where we offloaded supplies for the new German base at Neumayer, the ship was relatively stationary. So we had to do our stuff from the ship. And our first shock was to realize that the ship is never truly stationary. The engines would always be working to get the ship to stay in one position in the Southern Ocean and the very strong current around the Antarctic Peninsula. So that was our first shock. And then we had brought tailor-made traps with us, but these had to stay in the water for at least 24 hours. And of course, with the ship moving the whole time, so that didn't happen at all. So we had to go to plan B. So we started discussions with excellent technicians that are on board, and we started planning to have nets and other contraptions built for future work to gain access to fish and invertebrates. But what to do in the meantime? We were there now, so what to do? So we decided to collect plankton. Not exactly what we'd hoped for, but at least it was a start. We did take a teeny tiny plankton that you can see there in the bottom picture, and we started collecting. But we were 5 meters away from the water level, and our plankton net, we worked from the poop deck. This is the aft deck, which was the closest to the water, and this was still 5 meters away, and our net handle was 1 meter long. So we had to borrow a pole, and I say borrow in inverted commas because the bosun didn't know that we found his pole and that we were using it. So we attached this very long pole with duct tape to our teeny tiny net, and we would start collecting plankton in this way. And we collected quite a number of plankton samples in this manner. But now remember, think of us, 2 adults, fully clothed in Antarctic gear, that includes 2 thick jackets, beanies, and double gloves, rushing around on the poop deck in a frenzy from side to side to collect with a 6-meter pole. These shenanigans taking place on a ship with cameras mounted everywhere. Well, let's just say we must have provided some comic relief to the crew on the bridge on many occasions. We do aim to please, even if it is at the expense of ourselves. When we arrived in Cape Town after the first leg, I bought a piece of special plankton netting and also a fish net with a steel frame and lots of weights. And I started designing and making a net more suitable for the conditions that we had. And this is the net that we made. And it worked very well. We collected 2 full collection. Well, we had 2 full and successful collections. We still had to look out for wind action, boat turbines, currents, and so forth. The reason why we only had 2 collections is disaster happened when one of my team members, and we were only 2 in the team, decided one day, despite roaring winds and driving seas, not to listen to his supervisor, and in a flash, the aft turbine grabbed the rope and swallowed my uniquely handmade net. Gone in a flash. And the only thing we could show were blisters on our hands that worked through both the double gloves as we fought valiantly against the mighty turbine. Luckily, we didn't damage the work of the boat at all. Our captain was a stickler for the rules, and a keel haul in those frigid waters would have been mightily uncomfortable. But this was not the end of our scientific endeavors. We regularly collected water samples using the CTD, this very impressive apparatus, could go down to the bottom of the ocean and then collect in each of those canisters, 24 of them, each 25 liters at selected depths. So we could select the depths and then work through all those water samples for all sorts of animals. And we collected amazing organisms. It literally crawled with phytoplankton such as diatoms, radiolarians, and dinoflagellates, and also animal-like organisms, plankton, such as tintinnids, and copepods, and many, many more organisms. These are all photographs we took on board. And then a wondrous discovery. Initially, it had us gasping with astonishment. We collected 2 specimens of something that hasn't been seen very often. We found a very scarce little nunu, which we provisionally identified as a type of Pseudodendron, one of a radiolaria-like protist. These organisms hadn't been studied for more than a century. Those diagrams are from Haeckel that he made more than 100 years ago. These organisms produce spectacular constructions made of silica, which they take from the surrounding ocean, the ocean containing lots of silica. They craft perfectly proportioned glass creations. We collected 2 of them, as I mentioned, both of them with the symmetrical glass wonders, but some parts of their structures were not made of silica, but something else, something we unfortunately see increasingly very common as nanoparticles in the water column of all our oceans on Earth. Yes, they used plastic. Personally, I find this an unbelievable stain on the name of the human species. So finally, I literally took hundreds of photographs, and it was very difficult to choose between them which to show you. So I'd like to show you some of these pictures as background while I talk about the role of parasites and the role of research in Antarctica in general. The contribution of parasitological research does not only play an important part to determine the biodiversity of a place such as Antarctica, which hasn't been studied at all, but parasites are also used as important indicators of the health of ecosystems. Antarctica is undergoing large alterations due to climate change, also ozone depletion, introduced species, as well as the heightened attention on a global level. Countries are interested in its natural resources. Then there are also more and more tourists beginning to visit the area. Tourists and organizers of these tours, unfortunately, do not adhere to the treaty rules of this region. On a biological level, Antarctica is the center of evolutionary divergence and adaptations to a cold polar extreme. But this diversity and uniqueness are greatly threatened by environmental changes taking place over a much shorter time that would have happened naturally. And this is, of course, due to human influences. One of the main scientific endeavors in this region is to understand what the impact of past, present, and future environmental changes is and will be on biodiversity, as well as to understand the complexity of this part of our world, and to possibly predict what the consequences of these changes could be, not just on the Antarctic region, but on our whole planet. And parasite research can play its very small role for starters to assist to determine the health of this ecosystem. Antarctica drives many of our planet's vital processes, and the longer we study this area, the more we realize the immense importance of it. My final message to all of you is, should any of you ever get an opportunity to visit this part of the world, don't hesitate, please go. But this world left me speechless, yes, with the immense beauty of it, but also how extremely vulnerable it is. It left me very frightened. Daniel Costa had a warning for us, and I'm going to He said much of the world's weather is determined by what happens in the Antarctic. So understanding the Southern Ocean is key to understanding the whole global climate. End of his quote. It is my responsibility as a scientist, but all of us as fellow travelers on our planet, to conserve this part of our planet at all costs for the next generation, but also for our own survival. Here you can see where we were offloading the ship at Aktabukta, where we then took it to Neumayer, the German base. So lastly, I can tell you that for now, I feel exactly like Robert Murphy felt when he wrote these very simple but striking words. I now belong to a higher cult of beings for mortals, for I have seen the albatross. Thank you very much.